In order to answer exercise 9.4, you need to look at exercise 9.3. And what you need to extract from there is just one number, and that is the population standard deviation of 50. And so I'm just going to put SD right here, and I have it flushed. I'm going to add an equal sign. SD equals 7.5. All right, now that we have that, we are able to solve for the standard error of the distribution of the means, which is this part right here. And for that, that is going to be the standard deviation divided by the square root of n. So it's going to be 7.5 divided by the square root of 36, which is 6. Now I forgot to put the equal sign, so I'll put that there, and bam, already now we have our z-stat, which is negative 2.8. So this is a standard distribution of the mean graph, and so within this realm, our z-stat is going to be 0. Now if we go 1, 2, 3 z-stats, so negative 1, negative 2, and negative 3, this is at a negative 2.8. So that's going to be roughly, approximately like right there. Okay, now what makes this unique is that when we look at this z-stat, we're looking at basically what are the chances of getting an average that's going to be this low. So we're giving this average right here, that is the 46.5, which we were able to get from here. And it's not just a singular spot. We're no longer looking at the probability right here. Rather, what we are looking at is an average right here. So it's not a singular point. So in other words, there's basically another spot right at this spot, right at this area. So this is our population, and this is our sample, or our X bar. Okay, so explain why this provides good evidence against the null hypothesis. Well, the answer is if we were to look up negative 2.8 and see the probability of having a mean at this level, then our p-value is 0.0026. Okay, so if we move the decimal point right there, the chances of having a mean at this level with 36 people is going to be 0.26%. That's a pretty small number, and if I may, a significant number when it comes to our p-value. So then therefore we could say if our null hypothesis was that our average would remain around 50, and our alternative hypothesis is just not 50, with such a small p-value right here, and you can even just look at the z-stat, that's a pretty far jump over to the left, then we can say that the mean is not likely to have come from this sampling distribution, and therefore the null hypothesis is not a good fit, and it is rejected in favor of the alternative hypothesis, meaning that it is definitely a different group all in itself.